Hi, konbanwa minasan. Really nice to meet you. So my name is Guanyang, and I'm going to show you some information about our RVPJ, which is believed is first complete course of a computer architecture course based on RISC-V. So yeah, here we go. Okay. Konnichiwa, minasan. Hi. Today I'm going to talk to you about the RVPJ, the first complete computer architecture course based on RISC-V. We're from Imagination, and I'm a member of Imagination University program. We have created some teaching material that you may have heard about or maybe not, but we're really happy to attend Tokyo RISC-V Day to give you some information or some basic concept about what we are doing and what we are going to do around the RISC-V. So very nice to meet you, and hope you enjoy this presentation. The very important principle of Imagination University is we especially focus on doing. This means that we consider the process of teaching is not only something that teach the knowledge into students' head, but also the students should also know everything about how to build something or how to modify something. And after they finish all the courses, we are hoping that they could take away with something they could really use in their future careers. So this is really important for a student to understand, especially the computer architecture and electronic engineering world, which is a very practical subject. And I believe a lot of students choose to follow these two subjects or choose to put their careers into these two main subjects is because they really enjoy doing something or making something on their own. So all our teaching material is all our teaching materials are fundamentally focused on doing, and we also generate a set of a complete, which I will talk about later, a complete course for a teacher to use. So we consider a winning lab package or winning teaching material must have four key elements. So the hardware, software, support, and teaching material. I will explain it to you in a very detailed way. So the hardware actually means student could use a computer or use some hardware platform to generate or to run their labs to do something, as I said before, on their own. And the hardware shouldn't be cost in a very high or expensive price. In our 20 years of experience, we consider it had better to be lower than $200 cost. So if you consider to build a lab with about 20 or 50 hardware platforms, and some very expensive platform will cost you a bunch of money, which could be a burden if you consider for a sustainable lab to run. And the hardware also should be fully featured, and it should be proven to be in a good condition and proven for the application developers that they are already built a prosper community or ecosystem around this hardware. Also, it must be robust. You never know what your student will do with this hardware. They may accidentally break it or just for fun. So it has to be robust, and it also has to be debuggable. So the software. Well, we when we talk about the software, actually, it's for academic use. So we consider it have to be free for academic use, which means the teachers or universities will not cost money to buy the license and to use it freely. Freely means no limit, like no code limit or no time limit. I believe some of you must have been suffering from this code limit or time limit of software use for a long time. Because I think software could be iterated in a very short time. It could the language could be replaced by another. So why bother to use a very expensive software but only to use it for a couple of years? So it has to be free, and in the best condition, it has to be open sourced. So fully debugged as well, and it must. Teachers and students could get access to that through an online user license. The fifth thing is a pocket lab, which means we consider if students could take this software and hardware, if they could afford it, in their home, or when they have time to do some hobby projects. How nice it is. In my student age, I think if I'm really a hobbyist or enthusiast of technology, I'm really willing to build something on in my home, in my own PC, and if I could share it with my professor, that would be a very that would be what an amazing experience for me. So the support actually it means we should have responsive and active support. I believe some of you might experience something that if you are using a teaching material or hardware platform, you have nowhere to make complaint about what you have been through, like the processor has been burnt out, or you have no idea what the teaching material is talking about. So someone you could talk to is really important in this case. So we have a forum and community run based all our teaching materials. We have email that you could get access to us, and the best of thing is we have a bunch of engineers in our company or in our partners who are really familiar with what you are using, and they could give you very knowledgeable and useful support for you to go through your teaching materials. So the teaching materials itself is really important because we consider it not as a training material, which means it should be written by academics and for academics. And in this case, academics always know what other teachers or professors are willing to use, why they are willing to use, and what they are expecting. So all our teaching material is based around this principle, as well as this RVPJ, which I'm gonna talk about later. And the teaching material is not a training material that a company could use for their engineers training. It should at least last for one semester because the teacher are going to teach the student. They couldn't just set a class which lasts for a couple of weeks. So complete is also a very important principle, which means it has to be contained with slides and lectures, labs, and the guides, especially teachers and students how to set their labs, how to set the hardware and software environment, and test and solution, which is really great because teachers could prepare the test, the midterm, the final, and each lab for each course based around this test. And especially in the modern days, if you could see the professors teaching, there's no one actually sitting in the classroom. So I think we think the modern in modern days the online video is something really important for teachers and students to use and to understand the technology. So we will also generate a bunch of online videos for you to use, and you can use freely in your class. You could help use these to help you understand what's going on, and the students could. Or engineers, if you have finished your university, you could use these videos for you to train yourself or to get better understand of this technology. So we also believe in the train the teacher workshops, which used to be a face-to-face events all over the world. We have we have a very famous professor or someone who is really skilled with that to teach you how to use this technology and how to make full use of our teaching materials, which we believe it had really good feedback when we were running MIPS FPGA. And it has to be multi-language and global, which means if a technology is going to be successful all over the world, the students and the teachers, if they are accepting that, they also are going to facing the challenge or facing the opportunity all over the world that developers in many other countries are sharing the same technology, the same teaching material with you, so that this is the only way for a technology or for a company to be practical, to win success in the future. Okay, so let's go more into what we are doing. So we now have three aspects of teaching materials: the computer architecture, which you might be most interested with. We have the RVPJ, understanding computer architecture, this course. We will have the first part announced in November 2020, and the second part released in the Q3 of 2021. We also have a master level of this course. It's called Introduction to SoC Design, based on RISC-V, and this will be released soon. I believe it will come to you in March of 2021. So what we are going to do, we are planning to have a MOOC on edX, which you could get access to freely. I believe it is scheduled in 2021, and we also have a textbook. This is the very famous Digital Design and Computer Architecture RISC-V edition, written by Harris and Harris. As you may know, one of the Harris is the leading course author of our RVPJ course. And also we are going to have an ebook for developer, especially students, developer, and teachers. If you are interested in, it's called Guide to RISC-V. We will release it in November 2020, and the most important thing is this is a guide written by very solid and knowledgeable engineers. We wrote it together with DigiKey, the very famous hardware distributor in the United States. And we also have a course around mobile graphics and edge AI, which you may know. Imagination is a company, and our main income and turnover is from graphics, the IP of graphic card, of graphic processors, which you may know. So mobile graphic, introduction to mobile graphic version 2.0 is available now, and I believe it has been upgraded to 2.1. You could download it on our website, iup.imgtech.com, if you are interested in. And the hobbyist self-study package formed with the BeagleBone Black GPU. As you may know, the BeagleBone Black is a very famous hardware or development board, which has been sold millions all over the world. So we, based on that, built a hobbyist self-study package to run OpenCL on this kind of old-fashioned GPU. And also we have a Chinese MOOC on Xuetang X, and we believe it will come to the audience by this month. And we are also developing the Edge AI course using MediaTek's platform. It's called Pumpkin Board, and it's called Edge AI Principle and Practice. It will be released in May 2021. And we built this course together with PK University, which is famous in China, and very famous and knowledgeable university, UCM University of Madrid, as you may know. Okay, so let's start this evening's main subject. It's called RVPJ, Understanding Computer Architecture. And as you may want to know, that the objective of imagination, which we did not announce a major RISC-V product, why we are investing in RISC-V and and this course RVPJ. So we want to influence thousands of future programmers and SoC designers and establish imagination's reputation in RISC-V. And my colleague, Christoph Bees, will introduce to you some product that Imagination has been using in our in our graphic card in graphic IPs based on RISC-V tomorrow, and I will give you the detailed information later. So the basic information of this teaching material. The authors, Professor Harris from UNLV USA. She's one of the Harris in the book Digital Design and Computer Architecture. Professor Daniel Schever Martinez is from UCM, Spain. He's a very fantastic guy, very knowledgeable, and he has over 10 years or about 20 years experience in computer architecture, and it's just like the breathing and drinking water for him. For if you want him to talk about his knowledge in this area. And we also have a special author, Zubair Kakakal, and their teams. He used to be an imagination engineer, and now he's in Birmingham, UK, to start his SoC design career. And he's very experienced people in this sector. And we also have a guidance panel. The authors, even Kravitz from Platform.io, Ted Marina from Western Digital, Ali, Guanyang, and Robert. We three are from Imaginations, Technologies. So I remember Kawasaki-san just told us the languages, but actually we are very happy to tell you that the Japanese is right on our plan. So the languages will be English, Chinese, Spanish, and Japanese, and we believe the multi-language will of this teaching material will help to enhance the power of this community and will influence as many people as we want. So about the timing, so the RVPJ, as you may know, we have two levels of teaching material. The undergraduate level, which we believe to teach, which we believe will benefit a lot of students in their career, because if you take the computer system or SoC system as a car, so the very fundamental thing is to know how to build the engine. So that's the reason we are focusing on the undergraduate level of computer architecture education. So the first half of undergraduate level will be in January. We started January 2020, and it will be launched later this month. And we will have the SoC design course on March of 2021, and we will have the second half of the undergraduate level in Q3 2021. And also we will start to run workshops in Q1 2021, and we really want to meet you face to face if the condition allows us. So let's expect our upcoming events. So the status we have announced, and we are getting ready to launch later this month. As a platform we're using, the development board, we use the Nexus A7 by Digiland. The software we are using Platform.io and Xilinx Vivado. And we pick a core called Swerve Core. This is a very industrial level core written by Western Digital, and I believe this is a fully open source core which everybody could use, like teachers or students, if they want to build their own projects around this core. Is completely okay. And the textbook, Digital Design and Computer Architecture RISC-V edition by Harris and Harris, and it is going to be published by mid of 2021. So let's look at some detailed information about this course. So the target audience, it could be the undergraduate students in electronic engineering, computer science, and computer engineering. And as I explained before, we'd like the students to have a very solid and fundamental knowledge about the computer architecture and SoC design and related things, so the student could decide or could have a better future if they like to go deeper into master's course, or if they want to start their career, they must, or I have to say they really want to they really want themselves to have a very solid knowledge about it. So the RVPJ, the development team, we have a really good track record. As you may know, we used to develop the MIPS FPGA project. It is based on a real-world MIPS microactive core, and it launched in April 2015. And I believe Professor Amano, who gave her presentation just in front of me. He is also a keen user of MIPS FPGA course. So we engaged 800 universities worldwide, which means it is a very successful project, and we won the Electra Best Education Support Award in Europe 2015. So imagination about the RISC-V. We are a RISC-V user, and this information will be released to public the first time tomorrow. So we use RISC-V inside our GPU and connectivity IT products. So if you want to know more about how we are using this in our GPU, you could expect tomorrow's presentation with Christoph Beetz at 4 p.m. So the textbook, I've just mentioned it before. The core, we're using Chipline Swerve SoC. It is based on Western Digital's Swerve EH1 core, and you could see the structure of the Swerve core right by the right side of the slide. So some of our future plans. We are going to release 10 labs this November, and we are going to extend it from 10 to 20 labs, which could support undergraduate course from 1 semester to 2 semesters. And the SoC Design Master level course will be released next March, and the Global Trainer Teacher workshops will be started by the first quarter of next year. And we are also plan to have a bunch of online learning events like the videos. These videos will be recorded by the author themselves, the Professor Sarah and Professor Danny, and we are going to run MOOCs in English. It is on edX. Yeah, and teaching material package. RVPJ provides a set of instructions, tools, and labs that show you how to target a commercial RISC-V system to an FPGA, and add more functionality to the RISC-V system, which I believe students and teachers are really exciting about doing this, and analyze and modify the RISC-V core and memory hierarchy. So RVPJ understanding computer architecture, the undergraduate level, we will have our first release by November 2020, and it's about the part 1 and part 2, programming and I/O. We target the target audience is undergraduates and the predecessor course. We think the students should have a fundamental understanding of basic digital design and computer architecture. The students could expand their fundamental understanding of a commercial RISC-V core and SoC RVPJ, and a student could modify RVPJ to include additional I/O. This is what the first release of RVPJ Lab is going to teach the students. And the second half of this teaching material is about our RISC-V core and memories. It is more advanced for seniors, undergraduates to take, or even master students. And students could explore and modify the RISC-V core and memory system by themselves. And the RVPJ undergraduate package includes material for 1 or 2 semester course, and your course can build around all the subset of the material in RVPJ labs, which means if you like to take anything or anywhere you may think that is benefit for the student, that benefits the students, or that is appropriate for you to teach, or you just want to stick with your teaching syllabus but use 1 or 2 course or labs in our material, that is completely fine. We are going to support you or give you the complete access to all the slides, not PDF, and you can modify it and use it on your own as soon as it is non-commercial use. So something about the master level, RVPJ Introduction to Associate Design. We are going to release it in March 21. It's a master level course. It's a high level starter tutorial. Sorry, wait a minute. Yeah. It is an RTL focused course, and it is built on the SoC by adding GPIO, UART, and DDR onto it. And we use Zephyr, which is the operation system on the software, and we introduce it and how to interact the Zephyr with the RVPJ SoC. And we're going to release about 10 labs around it. You can see the hands-on labs there, and it is also going to be released in English, Chinese, Spanish, and Japanese. And we especially add the traditional Chinese, if any audience are interested, to show our hospitality to the traditional Chinese users. Okay, so when we were talking about the key elements, this is the fundamental elements of this course is using. So the software, it is free downloads from their websites. We are using Xilinx, Vivado, and Microsoft Visual Studio Code for us to edit our code and to build our program. And also we are using Platform.io. This is a chip alliance platform and includes RISC-V toolchain, OpenOCD, Verilator HDR simulator, and Western Digital Whisper ISS, which we believe is a very powerful, and they really gave a lot of support while we building this teaching material. And about the hardware, we are now using Nexus A7. The academic price is $199. Or if you are familiar with, we used to use Nexus 4 DDR FPGA board. It is also Digilant, and this board, Nexus 4 DDR, it was used in a MIPS course. So I believe some of you might be familiar with this. And actually, you could develop your own course, and based on your lab situation, you could use your own FPGA if it is needed. And as I know, the Swerve core is quite frequency friendly. The only thing you need to worry about is if the FPGA is large enough for you to use. So if you'd like to transplant this core in any platform you like, please feel free to tell us, and we are really happy if you could share about what you have done with our teaching material on our forum. And the RISC-V core and SoC, we're using Western Digital's Swerve EH1 core, and we're using the Chip Alliance SoC, Swerve, and the author of this SoC, Olaf Kindren, is also a member of our teaching material author or guidance panel. Okay, so this is about RVPJ Swerve EH1 core. What I like to emphasize is it is not a black box simulator, or it is an education core, which means, as you may know, many teaching material provided by company are going to give the students or teachers something called education core, which means it is quite frustrating for teachers and students to use if it is not it could not be used in an industry level. So it is also not a black box. I mean, what's the meaning of give a student a black box and input something and see the output? It is completely nonsense. So we are giving you a really a core from a real world. It is fully verified and in production and industrial grade level. So You could find out more about this core on GitHub. It is fully open sourced. And I'm really happy to tell you more about the sponsor, the contributors, and supporters of this course. As you may know, the David Patterson, the inventor of RISC-V himself, is our academic advisor, and he is the one who confirmed with our curriculum and gave us really good comments about our course and the vision of this RVPJ. And the authors, Professor Sarah Harris, Professor Daniel Sharon Martinez, and Rebecca Cacao, and a contributor, Olive Kindred, who is the author of Swervolve. And we have Portland State University, Professor Roy Kravitz, who is helping us to review our course to make sure that all the courses are suitable for academic use and for education. The basic sponsors are us, Imagination, and Western Digital, and we have a lot of supporters. RISC-V Foundation, very thanks to them for holding this event so that I could meet you. And Digiland, as you may know, they are the provider of this development board. And Xilinx university program gave us a lot of help on Vivado and on all the FPGA and software issues. And also Chip Alliance, thanks to them for their Swervolve SoC. Platform.io is giving us a lot of help in our software and environment. And DigiKey, the distributor, also CodaZip and Esperanto is also giving us a lot of help. Really thanks to these companies and people. So you can say this is not some company made up just made up a teaching material. This is a real solid collaboration between a lot of famous company, and this is as I believe is going to change the education sector, or to say change the future of the SoC and computer architecture. Okay, so a little bit summary what you will get from our teaching material. We will have a RVPJ getting started guide and teaching you how to install tools, download RVPJ onto the FPGA board, load and run programs, and simulate programs running on RVPJ. We also have a quick start guide. We'll teach students and teachers how to use our material. It is an abbreviated version of Getting Start Guide. And we're going to have 4 parts of RV Labs. Part 1 and Part 2 is going to release this month. And Part 3 and Part 4 is going to release Q3 next month. And we believe after completing the RVPJ course, the users or students or anyone from any company will walk away with a working RISC-V processor, SoC, and its ecosystem, and they could understand and know how to use and modify this core, which we believe is really fundamental and important for an individual knowledge for an individual to master and benefit his or her future career. So how to get access to these teaching material? All our teaching material is going to be released on our website. It is our support hub. As you could see, the forums, the events, the resources are all listed in the header menu of this website, and you could explore it when you have time. So it is the www.imaginetech.com/university, and you could also type in university.imgtech.com to get access to that. And if you are not convenient, by now you could just pop out your phone and scan this QR code, and this will lead you to our material. And you could register with us to be an active teacher, researcher, and student worldwide. You could register with us, and when the material is ready, we will send you a notification through email and telling you that you could download our material or if we have any event, we could send you messages. Please don't be worried. We will not send you spam messages, and we believe that all the information you might find this helpful and useful. And we have support forum, PowerVR developer forums, this RVPJ forums, and IUP forum for curriculum and teaching discussion. You can find it on our website. And we are also having brochures, event diary, teaching material, video tutorial, and we support a bunch of languages. And if you could follow us, if you want to give us more feedback, you could follow us on Twitter, Robert Owen, who is the director of the Worldwide University Program and Imagination Technology, and WeChat and Weibo, which is used in China. And really thank you for your attention and your patience. If you are interested in our teaching material, please feel free to get access to our website and download that. Thank you.